Well, good morning. My name is Deborah Williams. I'm a professor and chair of the Environmental Science and Sustainable Agriculture Department here at JCCC, and it's my pleasure to welcome you to our first Environmental Science and Sustainable Ag lecture series of the semester. We are in conversations to have more of these coming up this semester and hopefully more throughout the year. So it's great to see this great of turnout, and I've had several requests for recordings, so I think this topic must be very of appeal to the audience and those who couldn't make it today. Just a little bit about the series. We started this concept about 6 years ago, right before the pandemic, and the focus was to be on timely and relevant environmental science topics. When the Department of Sustainable Ag was merged with Environmental Science, we broadened the name to include Sustainable Ag as a theme of the lecture series. So you will see probably a mixture of both environmental and sustainable ag topics, and many of them, of course, are relevant. It's very cross-sectional and to other discipline areas as well. So it's my pleasure to introduce one of my colleagues who actually found the speaker for today, who knows our speaker, and I'm going to let Chuck Finley introduce our speaker. So Chuck, take it away.
Thank you, Deb. Well, we're honored to have as our speaker today the former director of the Kansas Bureau of Water. And before he was the director of the Bureau of Water, he worked for KDHE, the Kansas Department of Health and Education, for 27 years, first as a hydrologist and then as assistant director before coming director of the Kansas Bureau of Water. He holds a BS degree in watershed science from Colorado State University and an MS degree in forest hydrology from the University of Minnesota. Please join me in welcoming Tom Stiles.
This is a pretty small space. Can you guys in the back hear me without? Can you hear me without the mic? Oh, you want this in? Okay, fair enough. Thank you, Chuck. As he said, until this summer, I worked for the Department of Health and Environment, and actually, I think Chuck kind of backdoor got me for this. He actually heard a talk from one of my colleagues, Tony Stahl, at a water committee meeting probably down around Ottawa or somewhere. And Tony has spent the last 3 or 4 years really hunting down what these forever chemicals in Kansas look like, and with PFAS being kind of the poster child of what the issue is starting to embody and what it means to Kansas, and a little bit by extension what it is to the Midwest. I think you'll find in my perspective that I don't believe the Kansas narrative is exactly the same as the national narrative. We tend to have I think a little more moderate perspective of how critical this issue is. But the one basic truth is PFAS is with us, it's in us, it's everywhere. And that's the way it's going to be. And it's going to be a long time coming there. So how are we going to manage it, and how are we going to effectively deal with the consequences of this? We have become a very synthetic society. Back in the day, and I think well before everyone was born here, the chemical companies would roll out all these mottos, like without chemicals, life itself would be impossible. That was Monsanto's thing. And DuPont was better living through chemistry. 3M was science for life and all that. So they would prop themselves up as we're doing great things that will help further society. And society bought it. We now have, with these PFAS chemicals, tens of thousands of them now. And they were all basically, since World War II, kind of unfolded there, with an overall mission, really, to make life a little easier. And a little less some of the mundane tasks that your grandparents had to do became a little bit easier because of these types of chemicals there. These chemicals, and again, it was DuPont, Monsanto to a degree, and 3M, basically manufacturing these chemicals, discovering them that they had this unique property of this carbon fluoride bond, which is almost impossible to break. And that is part of the problem with PFAS chemicals there. And that leads to their persistence in the environment and their ability to accumulate in up the food chain and all living things. Over time, after the lawsuit, the consequences of acute exposure to them, the chemicals and the lawsuits and all that, there was constantly this move then to shift away from the longer chain compounds, like the two main culprits that embody the PFAS situation are PFOA and PFAS. I think they're eight carbon chain chemicals there with a fluoride attached on there, which makes them very, very resilient, makes them basically repellent for water. And as I've said, they're in everything. Examples. I mean, you can't get away from this stuff. I mean, the popcorn bag you put it into the microwave's got it. You go run down to McDonald's just across the street, and maybe they've changed it now, but the wrapper around the sandwiches, the hamburgers, etc. Well, that wax coating was PFAS, Teflon. Again, remember, the chemical companies were looking toward trying to help society improve itself. Teflon was huge. All of a sudden, you no longer had to sit there and just spend hours scrubbing away on your pots and pans. Stuff just slid right off. Gore-Tex, dental floss. One of the biggest things is also that it was a very powerful suppressant, and so it was used in a lot of firefighting chemicals there. And so it was very, very present at military bases and at airports, et cetera. Again, a lot of times with these types of things, it's a judgment call as to whether the benefits outweigh the risks. Early on, the benefits were just coming forward, not only in time savings, but in basically providing safety and other features that go on there. It was essentially miracle chemicals there. The problem is, as with most things, they're synthetic, and again, because they were so persistent, they stuck around. And so we're now living the legacy of what has gone on, the investment that society has made to basically utilize these types of chemicals. The health perspective really didn't come forth until around probably the 80s or so, starting out east in the shadow of some of these manufacturing companies where the chemicals were being made. Workers were exposed, people downstream and down gradient from these manufacturing sites were exposed, and they started developing a variety of health issues. And when it comes to these types of things, and as you learn through toxicology, everyone's a little different. Everyone has different sensitivities. Their own genetic makeup allows them to at times to be a little more resilient against exposure to certain things and so forth. So it affects everybody a little bit differently. But there have been known things there that basically the old adage that more is better doesn't apply here. Getting by with a lot of moderate or minimal exposure to that is a key toward healthy living there. So all these things are present there, and again, they are everywhere. Every time it rains, the rainwater brings down PFAS there. They have found it on top of Mount Everest. They find it in everyone in this room in their bloodstream has got some PFAS in there as well. So it is obviously a cause of concern because it's not natural. But that's what we signed up for back as we started investing in these chemicals. These are synthetic chemicals. We didn't understand then what the long-range implications are now. We're coming to grips with that now, and now we basically, and your generation is going to have to figure out, all right, at what level do we basically put in the appropriate safeguards there? And there are multiple ways to begin to push it back. I'm a big believer in thresholds, that once we cross over a threshold, it's impossible to get back to the way things are. I believe that here. I think these things are here to stay, but can we plateau it out so that it doesn't continue to escalate? I'm also a big believer that we're very, very good at combating acute impacts on us, which brought this whole issue to a forefront. Very acute types of situations that arose with personal health, et cetera. Chronic, well, that's not so much easily combated. And again, that begins to play into everyone's relative sensitivities there. So it's a very complex issue there, and a notion of, well, let's get rid of them is, I think, idealistic, and it's not going to be very realistic there. If we learned one thing during the COVID pandemic, it's that science will only carry you so far, but that people still retain that sense of wanting to make decisions on their own. And trying to take away some of these chemicals, which consequently mean, well, then we're going to revert back maybe to having to do more labor-intensive tasks. We don't have things as easier there. There'll be blowback. And we know that every now, given the times that we live in there, that there's probably never been a more serious time where science itself is under attack and people present their alternate facts and so forth. We don't have a real clear picture on the direction that needs to be taken. But moderation probably is the best path forward there, recognizing that we'll probably never get rid of these compounds. That carbon-fluorine bond is just, it's one of the tightest in nature, and it's almost impossible to break down relative to that. Again, with those longer chain compounds that started the PFAS train, they were there very persistently, and I think both of these have now been banned and are no longer being manufactured, but they still are present and they show up elsewhere. Again, the chemical companies began to, as they realized the consequences of what happened with a lot of exposure with that, began to go with shorter chain versions of the PFAS compounds to try to maintain the benefits without some of these longer range persistent and bioaccumulation problems relative to it. But each one of them, again, has little unique. The EPA is on a quest to eliminate the bad compounds and try to find the safe compounds so that, again, those benefits continue to be present and available to society without the health implications there. It's a daunting task to find that sweet spot to where these can find benign chemicals that perform like their predecessors. Bioaccumulation. Again, those of you that are dealing with toxicology and all that, again, you have acute exposures, which are basically one-off, and they basically result in dire consequences, lethality, and all that. But more subtle is accumulation or chronic accumulation over time and how that builds up and then how your body responds to that. And again, you have multiple pathways within water itself, but also through the food chain. I believe that for those of us that rely, like here on Water One, that our water supply is fine. That's not the pathway that PFAS that our exposure to PFAS is going to be problematic. In the reconnaissance that we've done with our public water supplies around the state, we have found very little PFAS present in our finished drinking water. That the treatment processes that have been in place to make that water safe and potable have been very effective at being able to remove severe consequences of the compounds there or that. Fish accumulation, fish consumption, I think is a more readily available path of exposure there. And I think it is also got a social aspect to it because of certain populations in the community that rely on sustenance fishing and so forth. They basically are pulling fish up and they're consuming those at rates that sometimes exceed what would probably trigger consumption advisories and so forth. Prior to PFAS, it was mercury and PCBs, et cetera. All those tend to accumulate there. And so fish consumption advisories have been designed to basically try to reward the benefits of incorporating fish in your diet, which is a good thing, without exposing you to an overdose of the chemicals that the fish have picked up by being present in the environment. All right, as I said, drinking water. I like Kansas's track record so far relative to that. We've done our own sampling, but we also have utilized EPA sampling across there. There are regulations now in place that EPA has established on certain levels of some of these compounds. And again, you're dealing with 12, 15,000 of these compounds. EPA originally just focused on 6. The science of this is slow in coming to understand what all the health implications are, and I think it will be basically, as with each year, more information will come forth on new versions of these compounds, and that'll indicate, well, there's some health implications relative to that. What EPA had was some science on 6 of the compounds there. Now, with the changeover from the Biden to the Trump administration, EPA has maintained PFAS as a priority, but has backed off a little bit of that. Of the 6, the only ones now that have got MCLs that are going to be enforced are, the original 2 bad actor compounds, PFOA and PFAS. Well, the other 4 basically have gotten pulled back for further study. I will say this, here in Kansas, among these 6, we see PFOA, we see PFAS, we see that first one, the PFHXS, and we see PFBS. We rarely see PFNA. We never see Gen X. I mean, never. We don't see it here. That's much more of, if you're in North Carolina, that is a big issue for them. We don't have it there. So, utilities, public water supplies have been doing sampling for a couple years now, and that'll continue through next year there. 92 of the utilities have got results there. They've got complete data sets now to begin doing evaluation. And the evaluation of whether or not they're in violation is a very complicated spreadsheet exercise to understand that you're dealing with averages, rounding off, et cetera. But in short, right now, among those 92, only 2 have got some results that are indicative of saying they're going to have to do something about that. Not surprisingly, one of them is around Fort Riley. Again, military installations tend to harbor these kind of chemicals, and there's a higher degree of probability of finding them relative there. So this will continue, but basically it doesn't get serious for the utilities until after 2030, when then they'll basically treat it like they do with most maximum contaminant levels in the water to make sure that they adhere to staying below those levels there. But again, the track record for finished water in Kansas has been quite good, and that has been a big source of relief for me in my previous life there, that this is probably not something we're going to have to worry about except for in some spot type situations. So then we switch over to recognizing, again, the stuff's everywhere. Under the CERCLA laws, or the Superfund laws there, the 2 chemicals, PFOA and PFAS, were identified as hazardous substances. That basically means they've got to be tracked. They've got to be reported and inventoried where they're occurring and when people are disposing of them relative to that. The trick is, again, because they are so persistent and that they're present in so many things, there are certain environmental mechanisms that are in place to protect and improve the environment that are actually acting as, all of a sudden, they become quasi-sources of it. Water treatment system, the treatment process, then reject waste streams from that. They basically are taking out the PFAS. That means the PFAS doesn't just evaporate into the air. It goes somewhere. So water treatment systems, wastewater systems, landfills. They're all basically working towards some environmental benefit. But in the process of doing that, they've encountered the unintended consequence of, well, we're holding this back, these wastes back, and PFAS happens to be riding along with them. We don't want to be liable for something that we didn't in ourselves cause, and we have all of a sudden now facing this type of issue as a result of us doing what we're supposed to do for environmental purposes, but PFAS now has complicated our lives. All right, when you deal with the Clean Water Act, which is the environmental side, the ambient levels in the environment, in streams and lakes, et cetera, we have water quality standards in place. Those standards tend to want to protect water, surface waters, to make sure that they're fishable and swimmable and drinkable. So aquatic life's protection is a key part of it. Recreation is a key part of it. With the aquatic life criteria that are established under the Clean Water Act, they aren't a big deal. This is basically reflecting what's protective of the fish. Doesn't cause mortality or morbidity in the fish populations. Fish are pretty tough. The numbers aren't important. What's important for you guys? Milligrams per liter. When we talk PFAS, we're constantly talking parts per trillion. These criteria are basically parts per million. Multiple orders of magnitude higher than what is being bandied about when it comes to, when we're talking drinking water, that's a part per trillion kind of thing, 4 parts per trillion. But when it comes to protecting the fish, we're 3 milligrams per liter, 3 parts per million. So there's a huge, huge difference in the level of protection necessary between what people view for human health as what is protective of aquatic life. Now, I wanted to point out 2 things. A general rule. PFOA was always viewed as problematic for us, humans. PFAS, not as much. But for fish, PFAS is the more critical compound that it might be problematic. But across the board with all this really, really was no big deal for us. When we sampled wastewater plants and what was coming out, it was in parts per trillion there. They would have no problem meeting these criteria. It's just not a big issue. When you look at it from the human side and how humans engage that, both in terms of drinking water, and this is drinking ambient water. This isn't what comes out of your tap. This is just ingesting it out when you're out on Clinton Lake or something. The numbers drop considerably, especially when you consider that the 2 pathways, ingestion of water or consumption of the fish that reside within that water, drive those numbers almost in the exact opposite direction that the aquatic life protection values are. These are now fractions of parts per trillion. These are parts per quadrillion. Basically, and this is below detection limits within the current technology. So to what degree, if it rains, we're busting these and all that. Now, EPA hasn't followed through and said these are going to be the criteria that are going to be. And the rule under the Clean Water Act is the most stringent criterion is the one that rules. If these became the criterion, these would be the rule. And we would be perpetually impaired because nobody can avoid getting, not having this level being present within the waters. Here's a snapshot. Again, this is Tony's work over the 2 years, 22 and 23, going out and beginning to sample that. And one thing he and I both agreed on, again, you're dealing with 15,000 versions of these compounds there. And if you just looked at one, well, that's going to tell you a little story, and then you look at another, but no one knows what the actual implications are. And he and I both early on said, let's not distinguish compound by compound. Let's just take the sum total of all detected PFAS compounds and just sum them up and say, that's what it looks like. there. So this is a blend of 3, 5, 6 different compounds that we found in ambient streams across the state. And again, you can see it's Kansas. So most of the water, surface water sampled, is in the half to 2/3 eastern part of there, just because out west in the high plains there really isn't. It's all groundwater. There isn't surface water to be had there. Big thing to note, again, this is why I've been very chill about the issue, at least from this perspective. The cool colors, the blues, and maybe even a little bit of the greens, just aren't all that prevalent. I mean, they're the prevalent ones, the hot ones, the warmer colors, a few hot spots, and that's all we got. Some down around El Dorado. Well, there's a refinery there. That's probably some linkage there. Shunga Creek in Topeka. Mystery to us why that is, but it might be because of a firefighting training exercise that's on the shores of the creek. It might be Billard Airport that the creek runs by there. We pick it up there. Down below Wichita, pretty heavy industry at present there. Yeah, we'll start to pick up some of that. But overall, for the state, not a real big deal for us to worry about. Here's a quick snapshot of what the streams have showed us there. I will say this one compound, PFBA, it's everywhere. And it's a degradation product of other PFAS compounds. So it's what we're finding everywhere. No one knows exactly what the health implication of that is yet. It's a breakdown product, and that's what we find almost ubiquitously across the board relative to what's out there. But otherwise, they're not seeing a lot of the two culprits, PFOA and PFAS, are 40 to 25% in the samples that have been collected. Not a big deal there. But a few hot spots like Shunga Creek or the Walnut River below El Dorado or the Arc below Wichita. Some of those areas do. And like with the Arc below Wichita, that's also below McConnell Air Force Base. Okay, well, you can begin to do some linkage there that maybe we draw attention toward. Look at lakes and wetlands, very much the same story. For the most part, in our lakes, it's just not there in worrisome amounts. This little red dot there is Ogden City Lake. It's an odd place to pick up a hot spot, except that it's in the shadow of Fort Riley. And some runoff might be coming off the fort down and finding itself. And remember, in Kansas, there's no such thing as a lake. Everything's a reservoir. They used to be streams. Every lake that you are in Kansas used to be a stream, and someone put a dam across it, and it became a lake. So it reflects the entire watershed that drains down to that place there. So these reservoirs are a reflection of their watersheds and what's happening there. But again, I look at the map and I go, well, this isn't all that worrisome. We got, a couple hot spots, but it's not that big a deal to us. Check our time here. Not good. Again, PFBA, that's the one that's everywhere. Like I said, it's the degradation product, and for decades, that's what we still see there. General rule of thumb, whether it's the streams, lakes, or whatever, the rural areas tend to be fewer compounds and lower volumes than what we see in urban streams. And that just logic flows from that. It makes sense because, again, for the industries that are utilizing all these chemicals, metal finishers, et cetera, they're going to be present for the most part in urban areas and so forth there. But in the rural areas, except for PFBA, there's just not that much PFAS out there. All right, the one that does get me a little more worried, and it's because the fish don't have an opportunity to find better water. The water that they live in is the water that they have. They basically are exposed there. Now, Tony tells me as he's gone out and done fish tissue sampling and all that, so far, not that bad. There's accumulation, and again, a few little hot spots there, down below Wichita, up on the Missouri River, but generally not all that much. We don't have a lot of fish tissue, but I believe that this is going to be the pathway that is going to be the most concerning when it comes to human health. And again, it cuts across social boundaries there because we have large populations that rely on this. Isn't just recreation, this is sustenance, and that they're going to utilize these fish to basically feed themselves and their families there. And to what degree do we hope that we can manage this again so it doesn't implicate them with health issues as a result of them pursuing this as a food source there. Biggest mechanism to deal with this type of thing will be fish consumption advisories, just like again we do with mercury. We have a statewide consumption advisory on mercury targeted toward more vulnerable populations, young children, pregnant moms. They tend to be the ones that we want to make sure really limit consumption. And this will be the same thing relative to when it comes to PFAS as it starts to develop into something that the state will issue annually, a consumption advisory on generally that. It typically is expressed as saying, let's try not, in hotspot, try not to eat more than one fish meal a month in the most extreme other areas. Overall, like with mercury, maybe one fish meal a week is adequate. And it depends on which type of fish. Bottom feeders tend to have more accumulation. The fattier fish tend to accumulate more. For fish, again, we looked at ourselves, compared it to our neighboring states and all that, and we're pretty much all in the same boat. So some are better generally in terms of the amount of PFAS. And again, with fish, PFAS is the compound of primary interest there. But there's not a lot there, at least in this limited data set there. Biggest thing is, again, as you consume a fish, and again, depending on the population, some people are selective. They just eat the fillet. Pretty low probability. Some populations, they utilize it all and all that. So whole body tends to ramp up your exposure probabilities when it comes to consumption. All right, let's flip it on the other end, the wastewater facilities. This is where I really, Tony was working on the environment end, and I was working on the wastewater end because I began to say this is where the regulations are going to come down ultimately of what the utilities are going to have to look at and treat. So again, they're collecting all these waste streams that come from residents, industries, commercial enterprises, et cetera, all coming in and then run into their treatment facility there. Wastewater is a biological treatment process where they utilize bacteria to work on the waste to basically remove it to a point where it's discharged into the Kansas River or what, and at levels that are not detrimental to, again, the uses that are being made of the river. Again, fishable, swimmable, drinkable. That process has tended to also pick up some of the PFAS. And because PFAS tends to gravitate toward linking in with organics, the treatment process takes out the organics. So it takes out the PFAS as well. And it winds up in the sludge that is removed from the facility, and then that typically is dewatered and land applied or disposed of in manners such as that. The biggest mechanism for improving the condition of PFAS delivery to our waters is going to be in pre-treatment. Pre-treatment talks about going out into the collection system, the industries that are discharging into the sanitary sewer, and working with them to say, don't do treatment here, take out the chemicals here, so they don't go into the sanitary sewer and then arrive at the wastewater treatment plant. We've got policies in place to make sure that the mixing zones of the effluent coming out of the outfalls from these wastewater plants don't cross over into intake, so that Johnson County wastewater discharge into the Kansas River is some separation distance away from Water One's intake of Kansas River water there. So those policies will continue to protect that. Again, on the drinking water side, we've been pretty stellar relative to that. Reuse is coming. There's an ongoing initiative to quit treating wastewater as a waste and start realizing it as a resource and to reutilize it. At its most simple, you see it as utilizing some of the wastewater to irrigate green space, ballparks, golf courses, medians, just all that. That's great. That's very good resource management. The question is, do we make sure that we don't inadvertently take PFAS and spread it out all over the place so that kids that are playing on the ballpark are inadvertently exposed to, out in the outfield, some levels of PFAS there. But generally, I talk about the wastewater, what we've seen coming out of the wastewater systems. It just isn't all that much. This is just a snapshot of industries and cities and what we've been doing. And again, looking at the total PFAS picture of all the compounds combined there and what it looks like. Camp Funston, that's Fort Riley. No real surprise there. Ellsworth, I might be industry there. Topeka North receives leachate from the Rolling Meadows landfill that basically, as it accumulates all the solid waste, well, there's water that accumulates down there, and that's shunted over to Topeka North to be treated there. It's pretty hot. And so Topeka North has got some things to deal with there. But as you can kind of see, it's just a widespread of the availability of what potentially is going to be out there relative to that. Again, from aquatic life perspective, these are all part per trillion again, against a criterion that's part per million. It's not that big a deal. But human health, these are going to be problematic no matter what they do. Here's my bigger issue. As I said, without even trying, wastewater plants are doing an environmental benefit, providing an environmental benefit because they, in part, trap PFAS in their treatment process. This bar chart is Wichita. There's 3 plants currently active in Wichita. The red bars are the PFAS amount coming into the plant. The blue bars are what leaves the plant. And as you can see, the plant itself is knocking down the PFAS and doing a good job of at least providing some relief to the environment from exposure. Here's the problem. PFAS doesn't just, like I said, it evaporates. It's around forever. So where's this at? This is in the biosolids, the sludge, which accumulates. And for mechanical plants, it's going to basically have to be removed on a every other day basis at least. And then they got to dewater it, haul it off somewhere, and it's land applied, et cetera. And it's actually a really good resource as a soil supplement, as a fertilizer. Farmers really like biosolids because it's a pretty cheap way to basically build up their soil, the soil that they're using for crop production there. For small towns, they utilize lagoons. Some discharge, some don't. But the same thing happens. They, over time, build up sludge. And every 20 to 25 years, they've got to go into their lagoons and dredge them out and desludge them. Well, they don't just leave that off on the side. They'll dewater that out, and then they run it out and land apply. There's the question. And that was the problem in New England. And that was the problem in Maine, where biosolids were being applied and PFAS compounds migrated from those sludges and those biosolids into the capture zone of public water supply wells. So Maine said, no more of that. We banned land application. And so that's created that. And that's been a spirit over in New England there. That's caused a ripple effect there going, what are we going to do? Because pretty much we got 115 or so mechanical plants and they all land apply. What are we going to do? We'll do it. We're working on them right now to see how big a deal is. Subsequent science is showing that for the most part, when it's a healthy mix of commercial and residential contributions to the wastewater going through the treatment plant, PFAS is very moderate. If you've got a heavy industry Yeah, sometimes I think that's what Wichita is facing, certainly. Or if you've got landfill leachate coming in, like Topeka North, then you've got potentially some problem, because that tends to be the more hotter applied biosolids that have been found out there. If there's a strong industrial signal in there, that becomes very problematic. But otherwise, things are, again, fairly moderate. Notice I'm not going to, I didn't say, well, we're going to eliminate it. Like I said, I feel like we've crossed a threshold. We will never eliminate this stuff relative to what is present out there. The best we can do is try to manage it and keep it down to manageable chronic levels that then again, our other system, our health care system and so forth, can recognize the implications and manifestations of that and deal with it accordingly there. But I don't believe we will ever get away from this stuff there. It's just a consequence of the investment society has made on this stuff. As I tell Tony and I, biosolids are really important for the ag community, and for them to utilize it. And because fertilizer, phosphorus, is a finite resource in and of itself that is going to, and you see it escalating in the fertilizer prices, et cetera. Biosolids are a very cost-effective way to build up a fertilizer profile in cropland, et cetera. Farmers are a little wary now. They've heard from their comrades out on the East Coast and up in Minnesota, Wisconsin, Michigan, where farmers are going, we're not taking biosolids anymore because we don't want the liability. In New Mexico, there was biosolid application in a field that abutted up against a dairy. Again, the PFAS compounds drifted under that, went into the water supply that serviced that dairy. The PFAS wound up in the milk of the dairy. They eliminated all the herd supporting that there. Now the good news is once they quit doing that with the PFAS, quit applying it, things reverted back and they basically could return to operation. But a lot of farmers don't have that luxury, and so they're weighing in, is the benefit of getting this cheap soil supplement amendment and fertilizer worth the potential liability I face if someone comes in and tracks up the food chain PFAS because of my operation there. There's ongoing efforts to figure out how to eliminate PFAS there. And again, it's tough. It's a tough nut to crack there. But you utilize it through certain technologies like pyrolysis that expose it to high pressures and heat to do that. Over at KU, they're looking at zeolite mineral compounds with their very web-like complexes that are really, really effective at trapping PFAS and basically winnowing it down to a manageable volume that then can be rinsed off the zeolite compounds and then disposed of in finite, and we don't have this huge amount of waste stream to deal with there. And both Tony and I believe there's no point in identifying specific compounds. You might as well look at the total PFAS picture there, because with each day, new study comes out that implicates one of the other compounds there. Plus, if you're a believer in synergy, that the whole is greater than the sum of the parts, and that was part of the philosophy of what EPA was looking at in terms of drinking water. One compound by itself may not be a big deal, but matched up with another one, and it creates a problematic brew that then has health implications there. Big believer that there's a synergy attached to these compounds there that, again, make their cumulative impact much greater than if we looked at them on an individual basis. With wastewater, again, I think the big issue, and again, my former role and what I do now is advise them on regulatory matters. It's going to be, to what degree are their permits going to have limits that are going to be triggered by protecting fish tissue from accumulating PFAS, and to what degree are the human health criteria going to become reality? Because when you're dealing with things at a part per quadrillion, I come from in my big passion when in my former job was trying to get there's no question, we have nutrients. We have too much nutrients in our waters. You see it in algae blooms, and you look out on a summer day across the river and it looks green. Well, that's all the primary productivity, feasting on all the nutrients in there. We've been at that for 30 or 40 years to try to whittle that down. We're making a little bit of edgeway, but not much. Here you've got things that won't go away. How are we going to manage these things again when we're looking at a part per quadrillion basis there? It's going to be a daunting challenge for all of you as you embark on this, as you start working toward environmental management and doing that. With the added on drama of post-COVID sociology, where you can say something because the science says it and it doesn't matter, someone's not going to believe you. And you're not going to create an inconvenience for them just because you think it might be problematic. Talk a little bit of groundwater. Again, out west in Kansas, groundwater is the primary source of water there. So far, very limited data between what USGS has collected or what K-State has gone out and collected. A few little hot spots, but generally it's not out there in any great levels there. It's there, but it's not in a worrisome concentrations on that. But groundwater will be tougher because once things are in groundwater, you have to treat it to get it out. It does not tend to self-remediate. It accumulates. Planned action on contaminated sites in KDHE. We have an environmental remediation bureau there that goes out and does groundwater cleanups there, trying to understand what levels cleanup needs to happen, not only for water or groundwater, but also for soils relative to that. Looking at where some of these contamination sites, we have no idea where the responsible party is gone. They're orphaned. So that becomes the state's responsibility. So trying to figure out to what degree does PFAS, have we inherited that along with taking on these orphan sites. Where we can find a responsible party, we'll transfer the costs for cleanup to them. But that's an ongoing challenge in and of itself. Complications, again, the permit limits for our wastewater plants. Synergistic impacts, that it's more than just one single compound. It's a blend of 20 or 30 different ones there. Our lab capabilities are fleeting right now. We have great capability to test finished water. Once the water gets murky in the ambient settings, the streams and so forth, certainly with wastewater, et cetera, it gets really tough to be able to get an accurate read of how much PFAS is in there. There's so many interferences that are associated with the processes there. The state lab has yet to set up and stand up the methodology to test it for some of the other things that are going to be more important than just ambient water, like wastewater, biosolids, soils, and fish. K-State has stood up a lab to do it. They're just now trying to figure out how to actually carry out those analyses, and they realize they're ongoing. Our friends that do solid waste management and manage the leachate from that, again, this is the example from Topeka that 900 parts per trillion and 140 for PFAS came into the North Topeka treatment plant there. Biosolids. That's the big number. 6,000 parts. Again, this was Topeka's biosolid. They just went and had it sampled there, which we couldn't do it. They had to ship it out somewhere, but they came back. That's a big number that you've got to figure out. How important is that once you put it back out on the landscape? Next steps there, again, we're helping. The only regulation that's in place is drinking water. And we'll help the KDHE will help the utilities deal with that. Again, we've only got 2 problem areas relative to that. We'll adopt regulations on all that. We'll look for opportunities to cooperate, like with K-State, to improve our analytical capabilities. We just have to continue to engage EPA, and we don't know where EPA is going to land in all this. And like I said, PFAS is a priority for them, but not as high a priority maybe as what was in the previous administration's agenda there. And otherwise, it's investigation of groundwater and surface water hotspots of where things are happening. Oh, and so this talk was just about emerging contaminants. PFAS is the tip of the iceberg. There's a whole bunch. Like I said, we're a synthetic society. Microplastics, we have no clue how much is out there, except it's everywhere, and we know that. Pharmaceuticals and personal care products, we've known that now for 20 years, that those are passing through us and are present within our water and within the environment relative to that. On drinking water, while PFAS may not be a big deal, natural compounds are. Manganese is starting to have some health implications relative to that. Now, we always knew manganese as an aesthetic problem, cause stained laundry, et cetera. There's health implications on that. And then the big one, as we went out and sampled all those finished water, the utilities and drinking water, didn't find much PFAS. We found lithium everywhere. And so that has said, uh-oh, are we going to have a lithium problem? And where's that coming from? I don't know, lithium batteries? I mean, it comes across. Lithium was an antidepressant. It was a medication at times there. But lithium right now, basically on the environmental front, is presenting itself as a problem with the proliferation of the batteries. And we're wondering if we're starting to see that migrate into water supplies. That'll be the next big challenge. That'll be something you guys will probably have to face to figure out how to ultimately deal with it relative to that. So there it is. Still got a little time left before the top of the hour, but I'd be happy to take any questions and try to elaborate on some of what I've talked about here. But it's been a pleasure talking to you. I'm not very much an alarmist, and like I said, I'm very chill about most of this stuff, but I do recognize there are little hotspot issues geographically and socially that I think we're going to have to focus attention on so that we can provide maximum protection to our population and to our environment.
All right. Just say I have some.
Yeah. So with it accumulating in humans, is that something that will just like stay, or is that something that like passes through our waste to some extent? Like, okay.
Everyone passes through, but it also will accumulate in your tissues. This is only can be attributed to me, but
He's saying you need the mic.
you know, RFK sits there and says some of the health maladies are happening because of vaccinations or Tylenol. I think it's PFAS. I think it's microplastics. I think it's some of this stuff that, again, everyone has different sensitivities to it. But I grew up I'm a child of vaccination and fluoridation. So, and I feel like I turned out okay. So I'm on that side of the debate. But this stuff, this is all synthetic stuff. And I'm not convinced that, at least there's an alternative hypothesis out there that some of this is manifesting itself in the rise in autism. Thank you. Yeah. That I think is something that needs to be looked at there and as a linkage there, because again, like I said, vaccines, I vaccinated my kids. My wife and I vaccinated. We never saw anything of it. But this stuff, this is different. We weren't exposed to a lot of that early on, but there's no debating the data, the numbers. There's a kick up, there's a rise. Something changed. So I just throw it out as an alternative hypothesis, something that should be investigated. But anyway, to your question, yeah, I think obviously we're passing it through because we see it in the waste streams, but we also are accumulating it. It is still coursing through us and through our bloodstream, et cetera.
Any other questions? Great.
And I don't remember if you said by 2030 we're going to have a bigger buildup in our bloodstream and in our bodies as well,
No,
or
no. What 2030, the water one and the public water, the utilities will all have to really manage PFAS so that it'll keep it down below those 4 part per trillion levels in the water that they deliver to you.
Okay.
So
Do
that
you-
they'll be on the hook on
Okay.
the regulatory front after 2030 to maintain that.
Do you believe it's going to grow more and there's going to be more by the time we reach further years?
No, I think it actually, I think there's so much awareness now, both in terms of the consumer as well as in the commercial and industrial, that I think it'll plateau a little bit. But again, I'm a big believer in thresholds. We've crossed over it. It will always be there. What will change, I think, is more implication of what the health implications are of a variety of these compounds there. Do that. I think there'll be, EPA again is on the quixotic search for good PFAS. They'll try to find those to basically introduce them there. But I don't see it escalating more and more. I think it will, at least the slope of the curve will drop a little bit just because of the awareness and the actions that have been taken to prevent its entry into the environment.
Have you ever tested the water in Flint, Michigan?
The water where?
Flint?
Oh, in Flint? No, that's Michigan. Our counterparts up in Michigan have done that. Now, Flint is notorious for the lead issue, really bad. They've gotten themselves corrected now to fix themselves up on that. Michigan is one of the leaders, though, in looking and addressing PFAS. A lot of the knowledge that we have has come from what we learned from Michigan and so forth. So they're really, really proactive there. And I guarantee all public water utilities are testing their water for PFAS to understand what it means to them. So it's not our world, it's Michigan's, but I have no doubt that they have data as to what the levels are there. And I hope Flint's gotten a break. They've had a rough time of it.
Yeah. Do you think you could compare the levels of PFAS to lead in our bloodstreams and in our environment? Like from earlier generations?
It's very similar. Lead comes at us from a variety of ways, and at the same time, while utilities are dealing with PFAS and making sure that lead is also certainly a huge issue under the Biden administration. The difference has been that in and of itself, it was never in the water. It was that the water would be somewhat corrosive. It was in the solder, in the water lines, et cetera. It was always out in the distribution system. And so there's been this huge initiative to get lead out of drinking water, out of the distribution system, both what the utility supports as well as what goes into your home, and to do that. I don't know that there's a correlation there. In fact, I would say there's probably a higher correlation that there might be some PFAS if the pipes that you have are PVC or plastic and so forth. That is a higher probability of having maybe some PFAS aspect to it than lead. But lead tends to act in the same way, and it bioaccumulates as well and causes that. Then, if you can remove yourself from it, it will also attenuate back down if you can remove yourself from the source of it and do so. But it's similar in acting, but I don't know that they're linked.
Great questions.
I don't know a lot about this, but there was a group of students here that won a project for the Cholera Cavaliers. Have you heard of that?
No.
Where they over 2 years did a project where they introduced plastic to algae and were able to get the algae to break down the plastic, and it had never been done before. They won a really big prize over it.
Right.
Do you think that's something that might be a possibility in the future to help combat these PFAS?
In both cases, I think yes. I think there are. While I say PFAS is very resilient, it obviously breaks down because we have that PFBA that's everywhere. That's a breakdown component. So it's obviously breaking down if there's enough time. The principal agent for breakdown is biological things. Algae certainly has played a part of that. Here's my issue is it breaks it down in its current form, but what's the fate of the degradation products? And I don't think, again, unless the algae basically absorb it into them and then they're stripped out of the water or whatever, there will always be some signal of that there. It may be, and I think that's the same with plastics too, is that they break down the macro molecules of plastics, but I'm not sure that they still captured all the microplastics because we don't know the degree. Nobody is, except for at the universities, given us a hint of how microplastics are present, other than the fact that they're just like this, ubiquitous. They're everywhere in what's going on there. So I applaud them because it's again, I think you got to me, what the algae attack is the acute problem, reduces it down to a level that's chronic, and then it's just a way to manage it that might be easy. You bring on a secondary treatment plan. What I find is there's no one single magic bullet. If you can create a series of treatment steps, then you've got some ability to, the first one takes the first hit but passes on, and the second one takes it out there. Treatment trains, I think, are going to be the wave of the future. Biology is going to be a big part of that because I think that is where a lot of the horsepower comes in being able to tackle some of these things.
All right, looks like we're over an hour and into our presentation and Q&A, but does anyone have one last question to ask?
I was curious if you find much glyphosate.
Oh, well, it's almost criminal, but we haven't sampled. Our lab's not the state lab wasn't set up to do glyphosate. It's been something that we have wrestled with of how to do that. But the answer, without knowing, the answer is glyphosate's everywhere. It's the most prevalent herbicide that's out there, and it's not just an agricultural thing, it's residential as well. We have no doubt in what USGS has gone out and sampled it there. It's everywhere there. The glyphosate is definitely in play.
Well, let's give our speaker a round of applause again, and also thank you for showing up today.